Hey y'all, welcome back. Today we are going to prove that infinitely many primes exist. First, let's define a prime number. A prime number is defined as a positive integer that has exactly one positive integer divisor other than 1. Prime numbers will be referred to as primes. Positive integers that are not primes will be referred to as composites. Primes are important because their existence lays the groundwork for the fundamental theorem of arithmetic, which I will prove in a later video. The study of primes goes back thousands of years. The ancient Greeks are often credited as the first to study primes. The Greek mathematician Euclid wrote Elements, which still influences mathematicians to this day. In Elements, Euclid wrote mostly about geometry, but in Book 7, he provides definitions, postulates, and proof concerning elementary number theory. In this proof, we will once again use a reductio ad absurdum argument, better known as a proof by contradiction. So if we want to prove that infinitely many primes exist and want to prove it using contradiction, we will assume the sequence of primes is finite. If the number of primes is finite, one of the primes must be the largest prime. Let P be the largest prime. Now multiply all of the primes in this finite set together and add 1 to construct a number Q, which equals 2 times 3 times 5 times all the way to P, and then add 1. Since P is the largest prime and P is less than Q, Q cannot be prime. So since Q is not prime, Q must be composite. As a consequence of being composite, Q must be divisible by at least 1 prime. However, dividing by any of the primes in the sequence 2, 3, 5, and all the way up to P will always leave remainder 1. Thus, Q must be a prime such that Q is less than P. This contradicts the assumption that P is the largest prime. Therefore, there is no largest prime and infinitely many primes must exist. QED, thanks for watching and have a great day.